right, so today's lecture is being held upon request from some student. All right, so those that wanted to have this class, so you can tell me what you want me to do today. Okay, some say they want to discuss past year. Okay, you want me to discuss past year, then you need to tell me which question you want me to discuss. Okay, I know you're all very busy this week to prepare for your video and prepare for your products next week. So for next week Monday, what I'm going to do is I'm going to do a summary of the course. All right. So in the summary, basically I will do a recap on the important points that we have learned. Also important concept that you should have learned. Yeah, and then from there, hopefully, you have at least a broad idea on the learning outcome of this course. All right. So again, your final assessment will also be assessing your learning outcome. All right. Whether you have learned or get a good understanding on the concept that you have learned all this time in this course. All right. As well as being able to apply them. All right. So as far as engineering courses is concerned, the most important learning outcome is application. All right. So you need to be able to apply the concept you have learned. So as far as assessment for this course is concerned, it's not about memorizing. All right. Again, because it's open book, so I actually reduce the amount of questions, the proportion of questions that require memorizing. There's no point in memorizing. All right. You can always access the information in the coursework because it's an open book. Okay, but having said so, no need to memorize doesn't mean that no need to understand. All right. So if you understand the material, then you actually don't need to memorize much, except for some maybe some equation you cannot remember. Then make sure you have the equation handy during the exam. Yeah. Um, don't wait until last minute only you want to get the equation. And in marking your assignment, I also find that some students use the equation wrongly. Come on, your assignment is open book. You are free to access everything. And you still give me the wrong equation. That one I really cannot understand. And if you use the wrong equation in the open book assessment, I have to deduct mark. All right. Well, and then okay, so I'll do that only on Monday. So I hope you will have some time from now until Monday to actually at least look through the material of the course that we have learned throughout the last 12 weeks. Yeah. And then next week I'll do a summary and hopefully you understand what I will be talking on. And also I'm in the process of marking your assignment. Okay. If I come across, as I mentioned before, if I come across anything that is suspicious or terribly wrong, and then if your diagram doesn't match with your discussion, your result doesn't match with your discussion, and so on, I will call you. All right, I will call you for Viva. So you have to do a simulation on the spot for me to see. I want to check all your parameters. Some of you did not put the parameter setting in your assignment. So I will call you and then ask you to show me your model diagram, show me your parameters. Yeah. So I will call you by sending you a private comment in Google Classroom. All right. So you better check your Google Classroom every now and then in case I ask you. Yeah, is that all right? Okay, good. All right, so what do you want me to do today? Past year, September 2020, question 2B. September 2020. Okay, what about it, Kalian? Okay, maybe I'll give you some idea, all right, on what how you should approach the question. All right. So when I discuss past year, I won't give you the exact solution, but I'll give you some idea on how to approach it. All right. So let me share my screen so that everybody can view the question. Right. Can you see my screen?
Yes, miss.
Right. So in question two, there are 20 machines to be connected to a data processing center. The machine and the processing center are located within the same building with distances not further than 50 meter and baseband communication is recommended. All right. So some of the machine produce analog information while the processing center only process digital data. So identify and describe the conversion process required. This one you should have no problem, right? And then this one, the next part, information from this machine is band limited to 1002 hertz. Good data accuracy, the error in conversion, blah, blah, blah. Determine the bit rate. This one also you know how to do, right? It's similar to your tutorial. Okay, B. If eventually all machines send information in the form of plus minus a valued rectangular pulses at the same rate as determined in question 2A2. All right. So what it means here is in part B, all the machine actually send their information in the form of rectangular pulses with the amplitude plus A and minus A. Yeah. And at the bit rate that you get from here. Yeah. At the bit rate that you get from here. And here, select a line code and a pulse shaping filter that is signal transmission and reception. Okay. This question 2B is an open-ended question. There is no one single solution. All right. There is no one single solution. So you are free to select of all the line codes that you have learned, you select one. All right. And you select what kind of pulse shaping filter you want to use. But whatever you select, it must be easy to transmit the signal as well as easy to receive the signal. Yeah. And you need to give valid reason for your choice. All right. So again, you select the line code based on what you think is good about it. Then you provide the reasons. Okay. Let's say you say, I'm going to select a polar line code. Then polar line code, then you give the reason why you want to select polar line code. All right. So you want to say, it's easy to generate, and the DC is 0, you know. And then you for line code, you also might want to choose between, let's say polar, you want return to 0 or you want to not return to 0. Again, both has its own advantage. Okay, the return to zero one actually will be easy to it will be easy for recovery because there is a self-clocking uh, feature inside there. Yeah, but if you are using non-return to zero, right? Return to zero actually, um, if there is no self-clocking unless there is quite a frequent change between ones and zero, then you can get from there. And but this non-return to zero line code will actually require lower bandwidth. Okay, non-return to zero will require only half the bandwidth of return to zero. So again, you provide any valid reason, you can get marks already. All right, and then pulse shaping filter, um, depends on what you want to use. You want to use R equals to 1 or R equals to 0. Again, depend on your choice. So you might want to say, I want to use a pulse shaping filter with R equals to 1. Okay, and then you say why you want to use R equals to 1. Because it's easier to generate, right? If R equals to 0, it's very, very difficult to generate in practice. But then R equals to 1 will give you, will require more bandwidth than R equals to 0. Again, you might want to discuss, choose whichever you like. So again, whatever that the reason that you give must match with your selection. Yeah. And then you are asked to compute the individual channel bandwidth with this selection, right? So as I mentioned just now, whether you choose a return to zero or non-return to zero, they require different bandwidth. And also for your power shaping filter, if you use R equal to 1 or R equals to 0.5 or R equals to 0, will also give you a different bandwidth requirement. So you need to calculate, all right? So again, this question, you need to give me the line code that you're going to use, what kind of power shaping filter you want to use, and make sure you give reasons for what you choose. And from there, you calculate the bandwidth, all right? Then suggest a suitable channel to be used between the machine and processing center with reason. So, so we are going to transmit data from machines. The machine is going to transmit data to the data processing center. And what kind of channel is suitable here? All right. So if you actually read the question up here, the building distance is not further than 50 meters, and then baseband communication is recommended. The keyword here is baseband communication is recommended. So now with the baseband communication, and then with your line code again is line code is actually in the electrical pulses. So definitely you cannot transmit with wireless channel. You have to transmit with a wired channel. All right, with a wired channel. So a wired channel will be a cable. So your channel should be a cable. All right, and uh, and then you should say a cable, and then your cable should give you the bandwidth that you need. All right. So again, your channel must actually be able to support whatever bandwidth that you calculated from here. All right. So you just need to say, in this case, a cable with whatever bandwidth, and that will be your channel. Then part three is the probability of error arriving at the processing center must be less than 10 to the power minus 8. Okay, assuming n naught of the channel is this much and the attenuation is not more than 20 dBm, determine the amplitude of the transmitted signal. Okay, and your answer must be based on the line code and the pulse shaping filter chosen in Q2B1. All right. So again, it depends on what kind of line code you choose, right? Then of course the amplitude of the transmitted signal will be different, right? Remember in our tutorial, we actually went through half wave, polar, or full wave polar, meaning return to zero or non-return to zero. It will give you, and eventually it may give you different amplitude. And then also, if you are using OOK, again, that will give you a different value as well. So everything goes back to what you chose here. So in when actually you get exam questions, always read the entire questions first before you work on the solution. All right, because if you choose a tough one here, you are going to have a tough time answering this part. Okay. Okay. So what else you want to know? You said clear enough, William?
So means for the B1, we need to compute one bandwidth or two bandwidth.
What do you mean one bandwidth? There's only one bandwidth, but
Okay. And for the same paper, how to prove 1D3?
one D3.
D, don't D.
1D3. Uh, this one is the based on the magical number 98%. Right? If 98% of the power is transmitted, then definitely it can be recovered with very low error or negligible error. So from here, basically, you need to compute the power ratio, how much power is actually transmitted. So in D, let me ask you in D, by reading the question, what kind of modulation scheme are you planning to use?
FM.
Yeah. So if you're using FM, then you work out the modulation index, work out the bandwidth requirement, all right. And then because you are going to transmit with FM, then you also have to make sure. That's why the part two is there. You have to okay. Let me share my. Okay. So in part two of the question, you are asked to explain the necessary steps to ensure the modulated signal can be transmitted within the standard and bandwidth allocation. So again, this one you need to refer to the international standard or the Malaysian standard at least. This talking about Malaysia or talking about uh, no, we didn't talk about Malaysia. So you can make use of international standards. So and then if you were to compute, you might find that the if you find the bandwidth that you need to transmit this signal as it is with the modulation index that you choose over here is more than the allocated bandwidth, then you have to talk about what you're going to do, all right, in order to make sure that the bandwidth of the signal that you want to transmit uh, is not less than the bandwidth that is allocated, all right. And then from here, then you need to prove that based on the steps that you have taken over here to ensure the bandwidth to limit your signal so that it actually does not exceed the bandwidth that is allocated, then you have to prove that with these steps taken, whatever signal that you transmit can actually be recovered with negligible error. So from here is basically you use the power ratio lah, to calculate the percentage of power of the original signal that you transmit based on this by limiting the bandwidth of the signal, um, how much of the original power is actually being transmitted. If it's 98% or close to 98%, then that you prove it lah. Okay.
Miss,
Yeah.
again for just now, question 2B1. Let's say
Mm-hmm.
I've chosen my line code to be polar, and
Mm-hmm.
then the bandwidth will be 2RB, right?
Polar. Depend whether you choose return to zero or non-return to zero.
Let's say I choose return to zero, non-return to zero. And then the bandwidth is 2RB. And
No.
then,
Wait. It depends whether you choose non-return to zero or zero, and what kind of pulse shaping filter you use.
then the pulse shaping will again affect the bandwidth.
Yes. Okay, let me just talk about this a bit further. Let me bring my okay. So let's draw your pulse. What kind of pulse you want to use?
Polar,
Polar, return to zero, non-return to zero.
non-return to zero.
So I'm going to transmit my A, non-return to zero. So this is my zero, let's say. Okay, it's going to be 1. So polar, okay, polar, that is going to be 0 will be sent at the negative amplitude, correct? Negative A. This is polar, non-return to 0. Right or not? And then the bit rate. So whatever the bit rate is, this is your TB. All right. So in this case, your TB is equals to 1 over bit rate. Correct? Yeah. And then what is the equation for bandwidth? Baseband. 1 plus RB over 2, right? This RB over 2, again, is based on this polar non-return to 0. But if you are using return to 0, then there is no over 2. All right. That's why your pulse shaping filter, the roll-off factor of a pulse shaping filter, will actually make an effect on the bandwidth requirement as well. Okay. So if you know the concept well, you can actually choose the easy one to work with. So in this case, you can say, yeah, if you actually polar non-return to 0 is a good choice, because you don't have to actually you don't have to remove these two. All right. If you are using polar return to 0, then your signal is going to be like that. This is your A, this is your 0, this is your minus A. So in this case, your 1 hertz bandwidth, only transmit 1 bit. All right. But in this case, your 1 hertz bandwidth basically transmit 2 bits. Okay, so it depends on what kind of signaling you use, non-return to 0 or return to 0. This is polar, return to 0. Okay, if you're using polar return to 0, then your bandwidth will be 1 plus R times RB.
Is this formula included in the lecture notes?
This formula is in your lecture notes. And this formula is based on your understanding on line code. If you understand this line code, then you will see that the 1 hertz bandwidth only transmit 1 bit. In lecture notes, we talk about ideally 1 hertz bandwidth can transmit 2 bits. That is because we transmit with this non-return to 0 line code. Then we can transmit 2 bits. All right. But if you're using return to 0 half wave, then 1 hertz bandwidth can only transmit 1 bit. So therefore, your bandwidth now is double of the non-return to 0.
That means for the lecture note on chapter 6, page 34, what is the bandwidth about on the graph?
Wait.
30, 35.
Chapter
Chapter 6.
Chapter 6. Page
35.
Chapter 635. Where got bandwidth there? This one?
This page. This page.
Yeah.
Please.
Yeah. Yeah, this one?
What is the bandwidth? The BW equal RB equal to RB is
This bandwidth equals to 2 RB, and this one also 2 RB. Again, it actually means the pulse shaping filter with R equals to 1. If you actually make use of the equation with R equals to 1, so therefore your bandwidth will be 2 RB, your polar code. And this is half wave. So again, if you put it into this equation, polar return to 0. Return to 0 is half wave. The pulse is half of the width of the bit. So you get 2 RB. Okay. Anything else? January 2020, question 4B3. Mm-hmm. Okay. What is it about?
The signal is corrupted and need to determine the average signal power.
Mm-hmm. So this question is related to part 2. All right. So to do this question, you need to first do this part first. And to do this part, you need to first determine this one first. What is your M? All right. So based on the M that you choose to use, and then you need to get your EB over N naught for burr to be lower than 10 to the power minus 7. So you need to get your EB over N naught from here, from this graph. Yeah. And then now in part 3, you have an N naught over 2 of this much. You get your EB N naught from here already. Yeah. Now you know the N naught over 2 is this much. Then from here you calculate your EB. Right? You get your EB. From EB you get your average signal power.
And what is the corrupted? The corrupted means.
Corrupted means noise is added lah. And then the signal is corrupted lah. You know what's the mean of corruption? Means noise added to it. So the signal now is uh, how to say corrupted. What's another word for corrupted? The signal is kind of a bit modified by noise. All right. And this EB over N naught, this EB over N naught is the EB over N naught at the receiver or not? All right. This is the EB and not at the receiver. So that means, so in order to have a probability lower than 10 to the power of minus 7, so again, depend on which M you choose. Let's say you choose M equals to 8. Then 10 to the power of minus 7 is here. All right, so if you actually plot this graph, actually this one is, if you do your assignment, you definitely can answer this question. So if you find the point, 10 to the power of minus 7, your EB over N naught is about 14 or 14.5. So you straight get your answer from here, your previous one, which is 14.5. All right. So again, this is in dB. It's in dB. So EB over N naught is 14.5 dB. Then you just rearrange your equation to get your EB. EB is equals to 14.5 times N naught, right? And then N naught over 2 is this much. So N naught is what? N naught is 2 times this one, right? Then you get your EB, correct? Yeah. And then when you get your EB, how you get your power? Energy per bit is what? Power times bit duration, right? So you rearrange your equation, you're just going to get your power. Okay. Good. All right. So as far as this paper is concerned, again, because this is open book, so I do not expect in some of the question there is no one definite answer. All right. Some have, some don't have. So whatever approach that you use to solve that problem, you need to give reason. Yeah, just like the line code, why you choose that line code, right? And what else? But in question four, I think the answer is pretty standard. In fact, the January 2020, there was still physical exam. So you can see that the question is not that open-ended. All right, it's not open-ended, meaning most of the time there is only one answer. But if you refer to September 2020, that paper is open book. So for open book, I don't ask any more theory questions like in January 2020. All right, so you can see there's a change of style there because of the nature of the assessment. Okay, for closed book, I will sometimes, and most of the time I actually ask the concept and theory questions. Right, but for online exam open book where you can easily copy answer and Google and get the answer and and straight away score the big portion of the marks, that will not happen anymore in a open book online exam. Okay, So that's why you actually, if you actually look at the September 2020, you can't Google for answer anymore. All right, and that question, that set of question actually require good understanding on the concept. All right, if you do not know your concept well, then you will have a hard time um, solving those questions. Okay, that's why I keep on stressing that you must understand the concept well. Don't memorize. As far as this paper is concerned, of course, there are some information. If you know the concept well, you straight away know what it is. But if you try to memorize tutorial answer, uh, I'm afraid you may not pass. Okay, don't memorize tutorial answer. Okay. And as far as this paper is concerned, because it's open-ended, so I would suggest you actually spend more time reading and trying to understand the question rather than straight away jump to solving it. All right. Sometimes if you misinterpreted the questions, then your solution will be very, very wrong. Okay, and you may not answer the question according to what is required also. Yeah. So just like in the midterm test, I asked for what is the transmission frequency? You know, oh, you just give me a range. I want a transmission frequency. Don't give me a range. All right. So if you give me a range, then it depends on the mark allocation. In some question, I say, give me justification. So if I need a justification and then you tell me this, according to international standard, this is a range, then okay, you get marks for your range. But if I ask for a transmission frequency and you give me a range, sorry, I can't give you a mark because I want one transmission frequency. I don't want a range of transmission frequency. Okay. Um, so make sure you read the question properly before you answer. In the test, I think some of you actually give me a range, but I did not take away the whole all the marks from the question. I still give you, I think, 1 mark or something by giving me a range. But uh, in the proper way, I should not give you any mark. Yeah, because I asked for one frequency and you at least give me a range. Okay, unless I ask for justification, then you give me a range, and after you give me a range, you still need to give me a transmission frequency. All right, don't answer half of the question, answer the entire question. All right, or else you lose mark for nothing. Okay, and then what else? So maybe let me brief you through again since we are on this. All right, so like this one just now, Q1D, provide justification for your selections. So this justification basically you need to give me the international standards to justify the choice. All right. So you need to actually follow this one. So the justification is by citing the international standards. And what else? Yeah, same thing here. Like for question 1A, part 2, uh, this condition, your suggestion must fulfill the following criteria. The value of A must be chosen that the power efficiency of the modulated signal is maximized. So again, you must give me a value of A. I need a value, all right? And also, X1T must satisfy the international standard frequency and bandwidth. Again, whatever you choose, whatever signal you choose, I don't want a carrier signal C1T. So give me a carrier signal. Don't tell me anything between this frequency will do. I want a carrier signal expression. All right. So this carrier signal, what is the equation for this carrier signal? What kind of carrier signal? If you don't want me to give me the equation, you give me what frequency. Okay. What is the frequency of the carrier signal? And what is the amplitude of the carrier signal? All right. So again, that depends on here. I ask for C1T. So based on this block diagram, what is C1T? Okay, and same thing here. I ask you to give me a C2T with justification. So C2T is another carrier. All right. So give me a carrier equation. What kind of carrier you're going to use? What kind of frequency you're going to use? Yeah, again, justification, meaning whatever you choose must be justified. So again, we are now working on AM. So make sure the carrier frequency you give me actually fulfill the international standards as well. Okay, so if you look at this question, there's no way you can Google for answer one. You definitely need to understand this block diagram, understand this thing that you are seeing here in order to answer this question. If you don't understand, if you don't know what is this, if you don't know what this means, there's no way you can solve this problem. All right, and there's no way you can Google the answer. Or you can Google for what is international standard for AM, what is international for FM. Of course, you can do that. But again, you need to know how to make use of the standard. By knowing Google and getting the standard alone will not help you to pass the exam. Yeah. Okay. So in your coming exam, the style again will be more like the open book style. All right. So it's no longer like before when you sit for physical exam, then um, where you don't have any reference material. So I don't ask for questions that are that open-ended. Okay, anything else? Minor. This minor only 2 questions. Only 2 questions, and then you have a total of two and a half hour to answer. So the final exam will be conducted in two separate sessions. That's two separate sessions. I actually break the 2.5 hour into two 1 hour and 15 minutes. All right. So we're going to release question one. Then you had 1 hour and 15 minutes to work on that question one. And after that, you have 15 minutes to submit your solution to question one. All right. Then we take a 10 minutes break, 10 minutes to 15 minutes break. Then after that, we proceed with question two. I release question two, then you answer question two. Again, that is going to take another 1 hour and 15 minutes. All right, so you answer question two within that 1 hour and 15 minutes. Then after that, when the time is up, you have again 15 minutes to submit your answer. Yes, you submit 2 times. All right, and then this time you're not going to submit with assignment style anymore. You're going to submit using a Google form. All right. Because in your test, some of you submit multiple answer. So I had a hard time picking which one is the latest one and which one you want me to mark. And in the final exam, you only submit once. You can only submit once, okay, using a Google form. So in the final exam, make sure you scan all your answers already. Okay, save it in one file, and you only submit one file per question. Okay, anything else you want to know about your final? In fact, if you want to know what the final exam is like, I think it's the same. Instruction is the same as the September 2020, the style. Which is this one over here. Um, okay, these instructions. So the first set of instructions is the standard instructions. All right, it's the standard instructions. But the additional instructions is actually written down here. So you may want to familiarize yourself with it. It's pretty similar. Okay, so as far as this is, the question will be released in two stages. All right, so you have 1 hour and 15 minutes to answer each question. So after 150 hour 15 minutes, you have 15 minutes to scan your answers. All right, save it as a file, um, and then you submit. There is no resubmission, and you also must submit within the 15 minutes time. After the 15 minutes is up, if you submit after that, will not be marked also. All right. Um, then you do not also, you're not allowed to submit any more answers after that. What else is this one? Yeah, and then another thing that you must take note is write. Make sure you write your course code, title, name, and ID. On your paper. All right, at least on the first sheet of paper, if not on every sheet. And I have students when I in the test, no name. I don't know who this test paper belong to when I mark. All right, no name, no ID. So I had a hard time going through the Google Classroom in order to look at the submission history to check which one is yours, who it belong to. So make sure you have your course code and name and ID written on at least the first page. Okay, and then when you submit, before you submit, you save the file as a PDF file. Don't send me photo. All right. Okay, save as a PDF file, and then you either use your ID as your file name or use your name as your file name. All right. Some in the test, some students just send as I don't know, a cam scanner file. The file name is cam scanner. Who is cam scanner? All right. So again, these are the things that you need to. I think you should be familiar with it already, lah. Since I think this is not the first time you are doing it, right? Last time also did this, right? So again, you'll be asked to actually sign on this declaration of originality. So as far as this is concerned, I'm going to put it in a Google form. So when you fill out the Google form, you're going to acknowledge this statement. All right, you're going to acknowledge this statement, and you fill in your information inside the Google form. Okay. All right, time is up. Any more questions before we end the class? Well, we are still going to meet next week. Next week, I think we can only meet on Monday, right? Wednesday is your products, huh? It's a big day, isn't it? So Wednesday no class, but Monday will be our last lecture. All right, so make sure you attend the Monday lecture, yeah, because I'm going to do a summary and recap the course for the entire semester, what you've learned in the semester. Okay, and what are the important points to take note. Okay. All right, if there's no questions, then we end the class here, yeah. Bye bye.